Welcome to the fourth video of the module 4. In this video, I am going to explain what is orthogonal property. The orthogonal property of the Bessel's function states that if alpha and beta are two distinct roots of Jn of x is equal to 0. Then prove that integral 0 to 1 of x jn of alpha x into jn of beta x dx is equal to 0 if alpha is not equals to beta. Proof. Consider jn of gamma x, lambda x is a solution of the equation x square d square y by dx square plus x dy by dx plus lambda square x square minus n square of y equal to 0. If u is jn of alpha x and v is jn of beta x, then the differential equations are x square u double dash plus x u dash plus alpha square x square minus n square of u is equal to 0. Let's call this as equation number 1. And x square v double dash plus x v dash plus beta square x square minus n square of v is equal to 0. Let us call this as equation number 2. Multiply equation 1 with v by x and 2 with u by x, which implies x into vu double dash plus v u dash plus alpha square uvx minus n square uv by x is equal to 0. Let's call this as equation number 3. Next, x into uv double dash plus uv dash plus beta square uvx minus n square uv by x is equal to 0. Call this as equation number 4. Subtracting 3 with the 4, we get x times of vu double dash minus uv double dash plus vu dash minus uv dash plus alpha squared minus beta square of uvx is equal to 0. Now the first term can be written as first and second term d by dx of x into uv dash minus u vu dash minus uv dash, that is equal to minus of alpha square minus beta square of uvx, that is d by dx of x into vu dash minus uv dash is equal to beta square minus alpha square of uvx. Next, integrating both sides with respect to x between 0 and 1, we get integral 0 to 1 d by dx of x into vu dash minus uv dash is equal to integral 0 to 1 beta square minus alpha square of uvx dx. That is, cancelling integral and differential, we get x into vu dash minus uv dash of 0 to 1 is equal to beta square minus alpha square of integral x uv from 0 to 1 with respect to x. On substitution of the limit as 1 and 0, the left hand side, we get vu dash minus uv dash when we put x is equal to 1 and 0 when we put x is equal to 0. The right hand side will be beta square minus alpha square into integral 0 to 1 x uv of dx. Let's call this as equation number 5. And we know that since u is jn of alpha x and this implies u dash is alpha jn dash of alpha x. V is jn of beta x, which implies v dash is beta of jn dash of beta x. Equation 5 implies jn of beta x into alpha jn dash of alpha x minus jn of alpha x into beta jn dash of beta x, where x is 1, is equal to 1 divided by beta square alpha square into integral 0 to 1 of x jn of alpha x into jn of beta x of dx. Since alpha and beta are two distinct roots of jn of x is equal to 0, which implies jn of x is equal to 0. Jn of alpha and Jn of beta both are 0. That is Jn of beta into alpha Jn dash of alpha minus Jn of alpha into beta Jn dash of beta is equal to 1 divided by beta square into alpha square of integral 0 to 1 x Jn of alpha x into Jn of beta x of dx. That is 0 is equal to integral 0 to 1 x Jn of alpha x into Jn of beta x dx if alpha not equals to beta. Hence the result is proved. Thank you.